Good morning. Today we're going to be talking about load limits in aircraft design. So pretty exciting stuff today, but it is important so you don't break the wings off on a plane when you're taking off or landing or in flight. So we're going to be talking about G-forces and how aircraft design and operations taking the load account. Alright, so we can't go through and discuss this like a class like we normally would. So we're just going to take a quick look at these videos and check out the test designs to ensure that the aircraft can withstand the high G-forces.
Force fighter pilots can experience force on their bodies that most of us will never even come close to feeling. To get ready, they practice here in the Air Force's Human Centrifuge.
We're at Brooklyn Base, and this is a centrifuge. This is what we use to train our pilots on G-forces. G-forces are pretty much, if you've ever ridden a roller coaster, you kind of get that feeling your stomach's about to come out of your mouth. That's kind of what G-forces are.
G-forces are forces caused by acceleration, and pilots experience them during sharp turns. Centrifuge spins. The pilot's body is trying to go straight, but the direction is constantly changing. This pushes the body outward. They call it a G-force, or gravity force, but it's actually a measure of acceleration. Acceleration is the change in velocity over the change in time. Velocity is determined by both speed and direction, so even if the speed stays the same, because the direction is constantly changing, there's acceleration. This outward force is called centrifugal force, and it's expressed as a multiple of G. An untrained person might black out between 4 and 6 G, but a trained pilot wearing an anti-G suit and using this training maneuver can go up to 9 G in the centrifuge.
So in physics, G-force is defined as accelerating force that causes an accelerating body to be subjected to a force opposite to the acceleration. The higher the acceleration, the greater the G-force. So an aircraft and its occupants traveling in a straight line at a steady speed experience only the force of gravity. That is considered to be 1G. So in accordance with Newton's first law, to change direction either vertically or horizontally, a force would need to be applied. Both the airplane and its occupants would resist that force. Newton's third law. That resistance is known as G-force. It is a measurement of gravity. It's not a measurement of gravity, but of acceleration. So this just gives you an example of what G-forces you would feel. So if you're ever riding a missile, you'll experience 100 G's. What movie was that? Dr. Strangelove. And I think a lot of us have experienced riding roller coasters before, so it gives you kind of an idea of what positive and negative G's are. So a positive G pulls towards the feet, so that's the pressure you feel pushing down. Negative G, feel you like lifting out of the seat. So any force applied to an aircraft to deflect it from straight and level flight obviously is going to produce stress on that aircraft. The amount of this force is the load factor. So load factor is measured in G's. So you can look at this table and see different load factors that are measured in G's for various angles of bank. So we can't have fun and go outside at school and do this, but this would be a good activity for you to go do. Pretty self-explanatory there, but you can see the amount of G's by spinning a balloon filled with water around. Alright, so hopefully we know why high G-forces make people pass out, because it's going to pull a person's blood into the lower extremities of the body and then reduce blood flow, and the head will decrease your vision, start graying out, and then a continuation of those G-forces will cause you to lose consciousness. So a load limit is how much weight or G-force a structure like aircrafts can support. So every aircraft can only support so much weight before it will break into many, many pieces. So hopefully you realize that an aircraft that could only withstand 1 G wouldn't last very long in the air. So an aircraft's maximum Gs are determined with the aircraft's gross weight, or the maximum weight for which the aircraft is certified. And that is in the handbook of the aircraft. So designing an aircraft with the greatest possible load limit would not be efficient. Therefore, the goal of the aircraft design is to make the aircraft light enough to fly, but withstand a certain number of Gs. Sorry, my dog's barking. I guess kids are winding it up. So, aircraft must be made from materials that are constructed in a way that are strong enough to withstand G-forces, but yet be light enough to enable wings of manageable size to produce the lift to offset the weight. So there's not a whole lot of materials that can be used. So in early days we talked about this. They might have used wood, fabric, wiring braces, which are very light but not very strong. And today they use mostly aluminum or carbon fiber, very light and strong. So, how many Gs do you think a plane must be able to endure in order to be safe? We talked about 1 G not being enough. So it's more based on what the plane's going to be used for. That's how they design it to withstand the Gs. So our normal category needs to be able to withstand 3.8 positive Gs and 1.52 negative Gs. The utility needs to be able to withstand 4.4 Gs, positive Gs, and 1.6 negative Gs. Then the acrobatic must be able to withstand 6 positive Gs and 3 negative Gs. So of course manufacturers want their planes to be safe. So as a rule, manufacturers over-design aircrafts to provide a safety margin of at least 50%. This 1.5 value is called the factor of safety, and it provides to some extent for loads higher than those expected under normal and reasonable operations. This does not mean a pilot should ever exceed those limitations, though. This is just a built-in safety feature. So this is the velocity versus G's diagram. So each airplane has its own diagram, which is valid for a specific weight and altitude. The red lines on the graph show limits beyond which structural damage or failure is possible. An aircraft in flight cannot exceed the limits for speed, load factor, and maximum lift capability without risking damage. So in order to avoid structural damage or failure, the aircraft must operate at combinations of speed and load factors within this envelope, which is why a V sub G diagram is also known as an envelope. So maneuvering speed is a speed at which a pilot can fully deflect one control surface, so our elevators, our ailerons, or rudder, in smooth air without risking damage to the aircraft. So it is determined by the aircraft manufacturer as part of the design and testing process. Pilots use maneuvering speed to perform normal maneuvers without overstressing the aircraft. So, analyze the point on this diagram labeled maneuvering speed. So remember that speed is also expressed as V sub A, is a speed that pilots use to perform normal maneuver without overstressing the aircraft. So for this particular aircraft, it shows about 135 miles per hour, and any loads must be less than about 4.4 Gs. Excessive speed and Gs risk structural damage. So turbulence can range from light to extreme. Light turbulence momentarily causes slight erratic changes in altitude or attitude. Moderate turbulence is similar to light turbulence but of greater intensity. Severe turbulence causes large abrupt changes in the attitude or altitude of the aircraft, and you might be out of control momentarily. So in turbulence, pilots should slow to an appropriate speed and stay well clear of bad weather. So we've seen this in our simulator. So notice here, the yellow area, that's our caution range. So it's between the maximum structural cruise speed, which is V sub NO, and the never exceed speed, V sub NE. So while it's permissible to fly in the caution range, it's possible to inadvertently exceed the load limit factors at these speeds. So you should never exceed the V sub NO except under smooth air. And obviously under no circumstances should you ever exceed the red line, V sub NE. So in light turbulence, it's a good rule to always fly less than the V sub NO speed and less than the V sub A in moderate or greater turbulence. And we'll talk about these speeds more in depth in a further lesson. Alright, so look at this and notice the red line labeled accelerated stall on the diagram, and blue portions of the diagram. The curved red lines show maximum lift capability, so that is that the aircraft is capable of developing no more than positive 1 G at 64 miles an hour, 2 Gs at 92, 3 Gs at 112, and 4.4 Gs at 137. Any load factor outside these lines is not aerodynamically possible because the aircraft will stall first. So, just want to make sure you guys see that the structural damage is shown in orange and the structure failure is shown in red in that previous diagram. Structural damage describes when a component is bent or warped but can be repaired. When structural damage occurs, a pilot may be able to recover, but repairs will be costly. Structural failure is catastrophic, meaning you will probably not recover. So an example could be like a wing or a stabilizer separating from the airframe. That would be structural failure. So the way you fly a plane will affect its structural integrity. So in an earlier lesson on weight and balance, we learned about the importance of operating an aircraft within its weight and balance limitations. Overloading or improperly loading an aircraft can put excessive stress on the airframe and flight controls. Pilots should never operate an aircraft outside the acceptable weight and balance range. Alright, so you guys can just read these, and I'll read them and wait a second, then show you the answer. So, the amount of excess load that can be imposed on the wing of an airplane depends on the speed of the airplane. Good job. So structural damage or failure is more likely to occur in smooth air at speeds above which one of these? You got it. Remember, that's the speed we should never exceed in the airplane, V sub NE. Alright, so we're not going to be able to do this activity because we're not together. So have a good day, and I will have the assignment posted below this video.